Hi, and welcome to our 24th test and measurement video on today's amazing oscilloscopes. Right now we'll revisit the Fluke handheld 190-502. There are quite a number of facets to this small instrument that come together to make it a powerful troubleshooting, educational, and research tool. In many instances, when an electronic device fails to perform properly or a prototype is prone to a baffling, complex, bug-like behavior, it boils down to a power quality problem. Some devices, like a common incandescent light bulb, don't care whether they are powered by an impeccable wave. In fact, if the voltage is within operating range, they will even not distinguish between AC and DC. In contrast, sensitive electronic equipment thrives on a high-quality supply voltage and often exhibits one or more failure modes when there is a problem in this critical area. This is true in regard to an external power supply, and the same observation is applicable regarding certain internal voltages. An example is the variable frequency motor drive DC bus, where a stable, ripple-free direct current is needed. The Fluke 190-502 Scopemeter, as its name implies, performs the dual function of depicting waveforms like a traditional oscilloscope and also taking voltage, current, and resistance measurements in the matter of a far simpler multimeter. On the top panel, this two-channel instrument has two oscilloscope analog channel inputs, one at either side, and between them a pair of banana jacks that will accept ordinary multimeter probes. To choose between modes, simply press Scope or Meter. To illustrate, we'll press Meter and take some measurements. First, a 9-volt battery. Notice that the voltage is 8.4 volts. This indicates only that the battery is low. We'll try another battery. Notice that the voltage is 9.35. That means it's a good battery, fairly new. Measuring AC utility voltage, the reading must be within normal range. Notice that the voltage is 119.9 volts, which is normal for a utility voltage. Next, we'll insert a 10-to-1 attenuation probe into the outer oscilloscope analog channel B and C input port. Switching into the scope mode, we see a phantom voltage. This reading is due to the fact that the channel probes plus input circuitry have quite a high input impedance, so that an extremely low voltage is visible in this auto-ranging instrument. We have powered up the same premises branch circuit, an electric drill. It has a universal motor with brushes which characteristically produce relatively heavy arcing. Notice the heavy distortion in the phantom waveform. The question is, does this distortion enter the picture through electromagnetic radiation caused by sparking from the brushes and conforming to the inverse square law, or is it conveyed through the AC power supply for the portable handheld oscilloscope, or is it embedded in the utility waveform as read through the analog channel input? First, an observation. The Fluke 19502 Scopemeter is capable of operating off the AC power line with or without the internal battery in place. If the battery is installed, and if it is good, it will be charging whenever the AC power is connected. A small icon that looks like an AC power plug is in the upper right-hand corner of the display, and it indicates the instrument is receiving AC power. When the AC power is disconnected, if there is a good charged battery in place, the Scopemeter will continue to operate. What happens when the probe is connected to the utility supply? Notice that the sine wave is much higher voltage than the phantom wave. Distortion introduced by the universal motor is no longer very prominent. This is because the oscilloscope, essentially a voltmeter, is auto-ranging. As a further experiment, we can disconnect the AC power to the oscilloscope with and without the probe sampling the utility voltage, and also with just one of the two probes connected. Also, try changing the distance between the probe and the utility supply wires. Is the probe acting as an antenna to pick up the electromagnetic radiation? The answers to these and similar questions will vary depending upon site-specific variables, as well as the condition of the drill and the presence of other ambient signals. Thanks for watching. In our next video, we'll look at the math functionality of the amazing Fluke 19502 Scopemeter. New videos are added periodically, so check back soon.